It's October the 30th, 1935. The most advanced aeroplane ever built to that day, the Boeing Model 299, now pictured, is publicly unveiled in an elaborate demonstration for the US military. Boeing, who built this plane, are feeling pretty confident. The Model 299 trounces the competition in basically every category, and a Seattle reporter has nicknamed it the Flying Fortress. What kind of cooler name could there be for a plane? But they're not taking any chances. The crew is formed of heavyweights from both the US Army Air Corps and Boeing themselves. The plane taxis onto the runway and it thunders along to a smooth liftoff, climbing sharply to 300 feet. At that point, it stalls, stands on one wing, and crashes to the ground in a fireball. 2 of the 5 crew are killed. What went wrong? An investigation identified no mechanical failure and instead pointed the finger at pilot error. With twice the number of engines as any other plane built to that day, the Model 299 was the fastest plane, but each engine had to be attended to separately. The oil fuel mix, the wing flaps, the propeller pitch, and more than that even, required near constant attention during flight. While attending to all of this across 4 engines, remember, the pilot had forgotten to release a new locking mechanism on the rudder and elevator controls. As it took off, the air was just passing over these flaps in completely the wrong direction, and it just flopped. Maybe it was simply too much plane to fly. Boeing nearly went bankrupt, but sold a few test planes to the US Army, and some Boeing staff maintained that the plane could be flown successfully. They put their heads together, and came up with a supremely elegant solution.
But the thing?
Yes.
You just press the...
Gotcha. They put their heads together and came up with a supremely elegant solution, the pre-flight checklist. It included stuff that all pilots knew how to do, and these are things much like checking your seat position and mirror adjustments in the car when you leave the driveway in the morning. And this was precisely because these kinds of really common things that everyone knows how to do can be forgotten in the heat of the moment. After making this one simple change, the test pilots went on to fly nearly 2 million miles without another single accident. And the US Army ordered 13,000 units of the Model 299, later naming it the B-17, and Boeing became solvent once more. This story and many others I encountered in a book called The Checklist Manifesto by an author called Atul Gawande. He is a top-flight surgeon in the US, a staff writer for The New Yorker, and a leader in health systems innovation. He's just a really fantastic person to follow. And this book changed the way I think about consistent performance in a complex world and how to get the most consistent and reliable performance out of the most complex of situations. It is a short book, it is a cheap book, it is really engaging to read. I thoroughly recommend checking this out. I'd also like to draw a distinction here between a checklist and a to-do list. A checklist is it's a response to a specific situation. It's very goal-oriented. It models a specific process, such as taking off a plane, preparing a plane for takeoff. A to-do list is not so much this. It's just a list of things that you need to get done today, for example. More than that, the checklist is standardized. That is, for example, the checklist for the Model 299 Boeing is the same for every Model 299 Boeing. There are no differences. And it is for other plane models, such as the ones that some of you may have traveled on recently. There is a standardized checklist for those, no matter which airline you fly with. There is a core set of steps that are the same across airlines, and they are customized slightly according to the different airlines' own processes. But the core of them, as I say, is standardized. A to-do list is very individual. It's much more focused on what am I going to get done or what is the team going to get done. Whereas, as I say, being a standardized list, the checklist is not individual at all. Quite often checklists are peer reviewed and tested and put through their paces to ensure that they fit the situations that they are modelling. The airline checklists, for example, are tested regularly to ensure that they are still operational under pressure and tight situations. They are iteratively improved as a result of that testing. And they represent a kind of fail-safe, a memory aid, if you will, for situations where you're under pressure and you need to be able to focus on the task in hand and getting that done. And quite often a checklist will point to other checklists. A step in a checklist may be an entire other checklist that you then have to follow. And in these last two respects, this is where the similarity between checklists and to-do lists appears. But really they are quite different things, as hopefully this slide makes clear. One key element of a checklist is when implementing it, when running through it, everyone must be able to stop the line, must be able to halt the process. Checklists are really only useful if a team commits to following them precisely and halting the procedure if a step is missed or completed incorrectly. For example, in the book that I mentioned earlier, the author mentions how he implemented a checklist for a surgical team that he runs, or ran at the time, sorry. And there is a hierarchy in the operating theatre between nurses and surgeons. Rightly or wrongly, it is there. And one of the biggest difficulties that he had was giving the nurses the authority to run through the checklist with the surgeons and stopping the surgeons from continuing with the operation if the checklist hadn't been followed precisely. So there are organisational issues around checklists as well. It requires the authority is delegated to the right people at the right time, and it requires the team to fully own their own work and to push back against outside influences. And it requires the outside influences to trust the team to do their job well as well. Can you imagine, for example, if a hospital administrator didn't trust the surgical team to do their job and said, oh, well, can we just forget about this checklist now? People would die as a result of this. And yet this is something that we actively have to push back against in the software environment because of the pressure to deliver stuff and deploy stuff frequently. So I'd like to talk about checklists in software. This is a software development conference. And it's quite likely that you are using some of these already, and you just may not know about it. So it's, as I say, it's likely that you use checklists in some parts of your development practices and your deployment practices as well, and we'll look at some specific examples of these shortly. Try to look for them more in different parts of your development and deployment practices as well. And automate as many of your checklists as you can with scripts. One of the really great things that we have as software engineers is the ability to automate stuff so much. And scripts really are just automated checklists. I'll be talking about that more later. So checklists in development. There are a couple of different places that we can use these. One that I've had some success with in my own team is when a story is ready to start. And how do you know that a story is ready to start? How do you know that you've gone through all of the sort of necessary steps to ensure that the story is clear and well defined and correctly scoped, etc., so that when a developer picks it up, they know what it is they need to do. And also the definition of done. This is something that I think is most common in sort of Scrum-based environments, and it's a really useful tool for being able to identify whether the work that is completed meets the standards that you have set as a team. So we'll look at an example story readiness checklist that I've used with my team. So to start off with, a story cannot be meaningfully split any further. That is to say, it's been sort of boiled down to its essentials, and it represents the smallest possible slice of functionality that is possible for that story. The acceptance criteria have been written. Acceptance criteria are almost like a mini checklist for that story. They tell you exactly what is expected to happen once this story has been completed, what the user expects to see as a result of the feature being implemented. If you're working on a web API, as I am at my company, then we ensure that the HTTP request and responses are defined for that story. Configuration schema for the services that you deploy or the application that you're running. The data schema for your databases, either NoSQL or SQL. And as you might have guessed, a number of these have sub-checklists as well. So I'd like to dig into the HTTP one for starters. So we look at this in a lot of detail when we're planning out a story. We want to ensure that our API adheres to good RESTful practices and good HTTP practices as well. And so, as part of the story readiness checklist, we ensure that we have agreed the URL path that the API action will serve on. The HTTP method that it will use has been agreed as well. What JSON it will accept in the request, and what response status it will return, both in terms of the success response status and the error response statuses as well. And in the case of success response, what the JSON schema for that response will be. For deployment as well, this is perhaps more comfortable ground maybe for the checklist idea, because in IT operations for some time there's been the concept of runbooks and playbooks. So runbooks are the day-to-day operations that you do, like provisioning a new database, for example, or spinning up a new server, etc. And playbooks are more specific to incidents. What happens when you've got a massive traffic spike, for example? How do you handle that? What happens if you lose connectivity to the database back in the system, etc.? And again, these are just checklists that people run through. And I'd like to walk you through one that we use in our company for deploying a new Kubernetes environment. This is, we deploy Kubernetes to Azure Container Services, which is great service for running Docker containers on a Kubernetes cluster. And the runbook looks a bit like this. We have a README document in our GitHub repository that describes these steps, and it is provision the new cluster, update the CI server that we use for deployment to that cluster with the new cluster credentials so that it can do what it needs to. Set up the secrets on the cluster, so the database passwords and external service passwords, API client secrets, all that sort of thing that our application needs to remain secret, we deploy to the cluster. Create the DNS records for our service running on that cluster. Deploy the infrastructure services that we have, and deploying the application services themselves. And this is precisely our process. I copied this out of the README document earlier today, and it is, it works really nicely. And a lot of it is now scripted, actually, as I'll describe later. And again, we have sub-checklists within these steps as well. Oh, sorry, public DNS. Yes, I forgot that one. So deploying the infrastructure services, we have traffic as a reverse proxy. We have RabbitMQ as our messaging system. Prometheus and FluentD are used for monitoring our service as well. Again, it's just a checklist. Do this, do this, do this, do this. Buttons to press. However, life is not completely rosy. Where a checklist would have been helpful and we didn't have one, I'm sure a lot of us have stories like this. A few weeks ago, I managed to delete our production cluster. Yeah, that went well. The issue that that I encountered was that the deployment script, the automated runbook that we have was not complete. It was a bit confusing to use. It accepted a parameter that would delete the existing cluster and overwrite it with a new one. It required a lot of parameters to be passed to it, many of them with the same value, and it was just generally a bit confusing. It was not clear to use. So I ran this script, and I think it failed the first time. I thought, okay, right, I've now got a half-complete cluster, so I'll run it again and pass the force parameter to really, really create it this time. And created it over the production cluster. I gave it the wrong name. That created a whole bunch of work for the rest of my team for about the next day. And that is an example where a checklist would have been more helpful, because running the script itself is a process. It's not just the script itself which automates the process, but actually kicking off that process is kicking off the deployment process is a process in itself. So now we have a checklist that involves things like ensuring that 2 people are present when the script is run to double check the arguments that are provided. We have also iteratively improved that script to remove the redundant information and the arguments that aren't necessary. And the script now automatically figures out the name of the cluster so that it doesn't overwrite an existing one. So checklists seem very simple, but they're actually quite difficult to get right, as maybe that last example illustrates. There's a few key points to bear in mind when writing a checklist, and the first one is that they have to be precise, really, really precise, like a surgical knife precise. It can't be vague in any way at all. They must be short. You might have noticed from the examples that I gave from our own checklists earlier that they're all approximately 5-7 items long. This is really important. They must be short because they have to be quick to run through. They must include only the most critical steps to provide the greatest efficiency of delivering the process. A good rule of thumb is to go for 5 to 9 items on a checklist, because the sort of short-term memory limit of the human brain is 7 plus or minus 2 items. It's not an absolute hard and fast rule, but it's a really good rule of thumb to stick to. There are 2 different types of checklist as well. There are do confirm lists and read do lists. So a do confirm list is one where you can carry out the process from memory or from experience, but then you go back and check your work, essentially. You compare what you did with the checklist. Some examples, both of the examples actually that I gave from earlier are examples of do confirm lists. You can do them from memory because they're not kind of time critical in some respects. Read-do lists, on the other hand, are much more interactive. You read a task out, you complete it, and then you verify that the task has been completed correctly and tick it off the list. And this is more like an incident playbook where you are under pressure to resolve the issue. Working through this step by step in a methodical fashion is going to be much more effective than using a do confirm list where you're still relying a little bit on human memory. The idea here is that there are built-in pause points in the checklists to evaluate the current status of it. So once you've completed a do confirm list, for example, you pause and check the work that you've done. In the read do list, you pause at each step and verify that step has been done correctly. Another key reason for keeping the checklists, especially the read-do lists, actually short, is that they must be focused. Otherwise, people start shortcutting them. If the pause points in the checklists are too long, say more than a minute or a minute and a half even, people will start shortcutting the process. It's just taking too long. I'm under too much pressure. I need to get on with the next one. So when writing your checklist, keep the pause points in mind, but keep them to a sensible length of time as well. And checklists must be tested as well. They're a response to a process, much like software is a response to process, and we all test our software, so we should test our checklists as well. Sometimes it can be difficult to test them in the real world. If we're talking about an incident response in an aeroplane, for example, it's very difficult to test an emergency on a real live flying plane. And this is why the airline industry has flight simulators, because they can simulate any error, any incident in aviation history, and try out the checklist in that scenario. The flight simulators, as I say, they are as much a test of the checklist as they are practice for the pilot's flying abilities. So I promised to talk to you about scripts. Scripts, as I said, are really just automated checklists. They are a sequence of steps that carry out a process that we want to complete. So techniques such as infrastructure as code, for example, that's just automating a runbook from operations. Incident response scripts, or other workflows, like there's a spike in the network traffic, ping the operations team or whoever with a message. Is again a sort of script, and it's the checklist process in action, but it's all taking place without human interaction, which is brilliant. Based on the experiences that I had with our cluster deployment script, I came up with a similar sort of set of tips for writing scripts, or writing automated checklists in particular. And the idea here is quite similar to the advice is quite similar to writing checklists in the main. The idea, minimize the number of parameters required. As I say, one of the reasons I screwed up that cluster was because there was so much information that I had to pass through. Include verification steps in your scripts. So at each point when a sort of subtask has completed, include a step to verify that completed correctly. Don't just rely on the exit code, for example, of the command that you called. call out to smaller scripts. This is like the nested checklist principle, but it's also the single responsibility principle in action. The cluster deployment script that we have is maybe 50 lines long, but there's so many steps in that overall process that we call out to 3 or 4 different scripts to handle each one of those. And this has a number of benefits. It means that if one of the steps fails for some reason, like the DNS provisioning that I mentioned, you can run that step again independently of the entire cluster deployment script. You don't have to start the entire process again. It also has the benefit of the code level benefits of keeping your code nicely factored. Think about whether you want your scripts to be interactive or not. Sometimes we don't want them to be too interactive. So the cluster deployment script, again, I don't really want to be kind of interacting with that. I just want to hit go and have it complete sometime later. Whereas an incident response script, I might want to be more interactive. And there's a nice parallel here between the do confirm lists and the read do lists that I mentioned earlier. A non-interactive script is more like a do confirm script. It's sort of go away, do the thing, and then check the process completed correctly. Whereas a read do script is more interactive, and it's do this step one by one. And there's a really nice sort of parallel with chat ops as well. I don't know how many of you are familiar with that term, but it's the idea that using sort of chat bots, essentially, in Slack or other team communication tools, you can interact with the process as it goes along in a sort of more natural way. GitHub has a really good talk about this somewhere that I'll try and dig out and put on the Twitter hashtag in a bit. I'll save questions for the end. The scripts, just like the checklists, have to be tested in the real world. So every time we improve our cluster deployment script, for example, we run a full test of the entire deployment process to ensure that it's still working correctly. To wrap up, as I said, you're already using checklists in some parts of your development practices. Look for them in more parts of your development practices. They're a really, really useful tool for guaranteeing consistent delivery. And use your checklist to guide the way you respond to incidents as well, because it will allow you to perform consistently under pressure as well. And finally, automate as many of your checklists as you can with scripts, because it removes the human error element even more than the checklist on its own does. Some resources before I completely finish up. Again, there's the Checklist Manifesto by Atul Gawande. Do buy it, do read it, it's fantastic. Manifestly is a really interesting tool for writing checklists and integrating them into Slack. It's not quite chat ops as a service, but it's sort of moving in that direction almost. And for your own personal checklists or ones that you want to write with your team, you can put them together in any kind of note app, really, Apple Notes, Microsoft OneNote, Google Keep, whatever. But you need to be careful to stick to the checklist format with these tools, because they're just places to capture text that also happen to support a tick box widget. So do bear in mind the tips that I've provided when writing checklists with those. Thank you very much for listening. I am Alastair Smith. Please tell me about your checklist.